Well, hello again, everybody. Welcome back to Tony's Bench of Humility. I'll just call it that today because, it seems like every time I work down here and work on something, I get humbled because I learn something new and realize that there's still a lot more I don't know. And it's one of the things that's neat about this hobby is that you can never learn it all. No matter how hard you try, there's always something new to learn. So the reason for this video is I'm going to try something new. I know that I've done a couple of viewer comments follow-ups. So, and I've gotten a lot of positive feedback on that. So what I really want to do is once a month, I want to try to get one video per month to absolutely be able to address all of your questions and comments. Now, there's a lot of you out there who really enjoy watching YouTube, and it's almost become your new form of entertainment instead of television and things. And I think a lot of us are in that same boat. I know I am. I hardly watch TV anymore. I do watch, the baseball games and some things like that. But really, there's just so much that I'm not interested in anymore on modern TV. And what I've found is there's a lot of people who have similar interests to me. And you post things, and I'm a heck of a lot more interested in what you guys have to say than, some of the things you see on TV these days. So it's kind of become my new form of entertainment, as well as doing this sort of hobby. And I'm sure a lot of you probably, the feeling's mutual. You watch these things, but a lot of you probably don't have the time or whatever to make videos, to post your own. So what I thought I'd do is I'd come on here once a month and try to share with everybody some of the comments and questions that I get from month to month. Now, a couple of rules here. Number one, I don't want to, I'm not going to share people's names and things like that. I don't think that's appropriate unless you request that I do so. So first of all, we're going to keep things confidential that way. Number two, let's just use this month for an example. In the last 25 to 30 days, I've had almost 200 comments. All of them are good comments. All of them are things that either, I really appreciate, the positive feedback that I get from some of the comments. And some of them are very useful comments that, the suggestions that you all have and observations that you've all made from the videos or sharing your own experiences. And I think those kinds of things would be beneficial for everybody if I was able to share them with others. Because I know some of the things I've heard from you guys, I've learned, guys and gals, I should say. And so therefore, I'm going to try to pay it forward. So that's the first thing. So that's what this video is going to be. Now, I want to try to streamline the way we can do this. So comments are great. I like the comments. If there's something more specific, like a tech repair question, one of those, can you do a video on, or perhaps a video or a question about, would you be interested in repairing this device for me or something? Let me give you two methods to communicate with me for that might make it easier than having me sift through all of the comments, okay? The first thing you can do is you can go into the YouTube website and you can just send me a private message, and I'll try to walk you through how to do that, okay? So let me get a YouTube site up, and I'll try to walk you through the process. Okay, so as you can see, now I can't pull up my own YouTube site because it displays different because it's me instead of, but let's use this is a popular site that probably all of you are aware of. I mean, we're all familiar with Dave Jones at EEV blog and all the wonderful work that he's done. But let's say you want to send a message to a YouTube channel owner like this. Okay, so my site will be the same. Okay, when you go to my YouTube channel, so you go to the front page. If you go down to where it says About, and you click on it, and that brings up the information about about the channel that the person posted. But if you look up here in the corner, right here, there's a little button called Send Message. And if you click on that Send Message button, okay, let me zoom you in, right there. If you click on that, that will open up a little page that allows you to send a message. And if you click that and send it, you can mark it private or whatever you want to do. That'll just send the message direct, and it's linked to my email, so I'll get it through my email as well. So that's one way to do it. Okay. Now the other way to do it would be to send me a direct email, and I don't have my direct email address posted on my YouTube channel because it's really easy to get a lot of spam that way. And I know all of you will be loaded with a lot of suggestions of ways to get around that, like putting in a CAPTCHA or something like that. But I just haven't gotten around to doing any of that yet. So for the meantime, until I can get some time to do that, I'll just share with you my email address that you can type in, and it's XT. Okay, so, and let me go from portrait to landscape. Let's see here, page layout, orientation, landscape. There. So if you look, there is my email address. Okay, now this is a separate email address strictly for my YouTube channel and doing private repairs and things like that. Now I do take on repair jobs. I don't just repair Pioneer. It just seems that way from the videos. I get so swamped with people that have Pioneer gear. It must be very common out there. So I get a lot of it. So that's why you see so much of it. But I can service pretty much, most of the gear that's out there. Some stuff out there requires some special documentation or some special test equipment that I may not have. If that's the case, I'll let you know that. I don't take on any job that I'm not very confident and comfortable to do. And I also kind of limit my jobs to a case-by-case basis based on, number one, how much time I have. You have to realize I own my own business and run it, which is a full-time thing. So, I still have a family to deal with. I have a wife and I have children. So I'm very busy, but again, this is kind of my therapeutic time to come down here and work on this stuff. So it's really not entirely extra work for me to do this. I actually enjoy it. I enjoy sharing things with all of you. And even though I don't know you all personally, you come to appreciate the comments and the kind words. And it makes me feel good when I can help somebody else out, or even just entertain them for an hour or so while they watch a video of me stumbling around trying to fix something. So feel free to email me. Again, it's all about quantity. If I get a ton of emails and messages, I can't always get all of them. I'll do my best to filter through them and get to them as much as possible. But please don't feel offended if I don't get right back to you, because sometimes things get really busy at work and at home, and I just don't have the time to put into it that I'd like to. So that's the first thing. I'm going to try to follow up on all of the comments in this video, and like I said, with 200 of them or so, I can't get all of them. So what I did was I've read through all of them, believe it or not. I try to keep up with that every night. I go through them. And I've basically taken some shorthand notes and I tried to combine the questions that are similar into one generic question that hopefully, if I answer it, it'll answer all of you, or at least mostly answer all of you. So that's what we're going to try to do, and that's the format that I'm going to try to follow each month as I do these, viewer questions and comments videos. Okay, so first let's start out. First part of my video is I want to just kind of give you a little rundown of the upcoming videos that we have. The first thing that's coming up pretty soon here is going to be a Pioneer. I got some schematics printed out here. A Pioneer SX525, and it's a pretty interesting little amplifier or little receiver. It's only rated at 10 watts per channel, but when you hear it, I think you're going to realize that it doesn't sound like that. It sounds like a lot more. Again, it's Pioneer gear. I get so much of it, I can't even tell you. But bottom line is, interesting thing about it, the schematics are a little bit different, the service manual, than on some of the other ones we've serviced. For instance, there is absolutely no, if you go into the alignment procedure for this thing, here's the alignment procedure. It goes into all kind of detail about doing the, doing the tuner section. Absolutely nothing about setting the bias on the amplifier. So we're going to have to go through how we would calculate how to set bias on this thing when we don't know what it's supposed to be. So that should be a little bit of an interesting video. It has a couple little issues with it. I did a preliminary checkout for the owner. I always try to do a checkout for the owner before I decide to do a video or decide to do the repair. I inform them of what all it looks like we're going to be involved with, and then they have the option of what they want to do for the repair. And then if everything's good, they want to go through with the repair. Most of them ask for me to do a video, and so of course, I'll do the video of the repair as well. Sometimes people don't want to, but most people do. And if I have the time, I'm more than happy to do that. Okay, so that will be the next one you'll probably be seeing coming up. A local local antique store is going out of business, and they're either going to move to a new location, or they're going to sell off all their product. And long story short, I'm not going to show them to you in this video, don't have time, but I purchased 6 small table radios, Zeniths, and some Radio Shack, and some, I think maybe a Westinghouse, a GE, some different ones. They're all interesting, and we're going to try to do a repair on all of those. Those are going to be little time wasters. None of them are fantastic shape, but they're just going to be really fun. Some of them are solid state, some of them are vacuum tube. I know people love the radio repair videos, so we're going to do that. And each one, I'll try to do something a little bit different to share some of the techniques that I know. All right, so those will be like sprinkled in between, bigger projects. If I just want to do a quick video or something, we'll do a little time waster, and I'll share that with you all. I currently have a DeVry vacuum tube oscilloscope from the DeVry Electronics Institute, which is now defunct, I think. I'm not sure. They might still be around. Purchased at a flea market, another little $10 or $15 thing. I've always wanted a vacuum tube oscilloscope. I had one when I was really young, and I ended up getting rid of it when my parents sold the house and moved out and everything. My father passed away, so I had to get rid of a lot of stuff, and maybe one day I'll share with you the story of some of the things I got rid of. I think you'll all cry. Like things like that I didn't know what they were worth. Like I had a Tannoy dual concentric 15-inch driver I purchased at a flea market for like $10. I'm seeing them on eBay, just that raw speaker selling for hundreds of dollars, upwards of $1,000 for that speaker. It went garbage. I had just gotten married, and things were crazy in my life, and you know, kind of got out of this hobby for a while as I was trying to build a life for myself and my new wife and everything. And you look back and youth is wasted on the young, huh? Hindsight's 20/20, all those sayings. But anyways, so I will do that oscilloscope video. I have a video I've been working on a very long time, and it's going to be, I'm going to try to do my best on it. It's been a very difficult one for me to, you know, put together in a reasonable manner, but I'm going to do a video on radiation. And when I say radiation, I don't just mean X-rays. I mean the different types of radiation, like ionizing versus non-ionizing. You know, what a X-ray out of an X-ray machine versus, you know, radioactivity. What sonic radiation is, what ultrasonic radiation is, what, you know, RF radiation, electromagnetic. I want to try to get into that and answer some of the questions. I hear so many things. I mean, that's the thing that I do for a living, is I work with X-ray. So, you know, I'm by no means an authority, and I'm not a radiation physicist. Okay, let's just get that out of the way right now. But I have a little bit of an understanding of it, and you know, if I share that, maybe it would help answer some of the questions out there that some of you have. So we're working on that. I'm also going to do a follow-up video on the guitar amp and the bass amp, so be looking for those. And again, all of this is going to be spread out over a long period of time because, you know, things are busy, and I'm sure other things will pop up in between there. Okay, on to the questions. All right, one of the things that I got was a viewer had commented, you know, when I said that they just don't make them like they used to. Okay, sorry about the static image here, guys. Don't have much, just as most of this is talk, this first little part. I do have some visual things for you guys too coming up. So modern equipment build quality. I made the comment that they just don't make them like this anymore, and that's kind of a cliche saying, and it's partially true, but it's not totally true. And a viewer did not, I'm not going to use harsh words like he called me out on this, but he did make the comment that, you know, in fact, if you wanted to make the investment, there are manufacturers out there still making very good equipment. And a couple that he brought to mind was the modern, you know, some of the modern Marantz equipment. If you buy the really high-end stuff, Yamaha is still making some very high-end, and I'll even add to that. I mean, Macintosh is still alive and well out there, and they make some fantastic equipment. There's some companies, when you start getting into tube gear, I can go forever on them. There's quite a few really good ones out there. There's some not so good ones, but there's some that are pretty high-end. So, you know, by all means, you can still buy it. The thing is, the money that you'll spend is like it was back then. You know, the things that we're working on that were hundreds of dollars back then would, in today's dollars, be thousands of dollars today. And they are. So if you buy top of the line, top shelf stuff, expect to spend thousands, many thousands. And when I say many, I mean I've seen people drop $100,000 on a stereo and not blink an eye. I mean, it can easily go that. You know, $5,000 is just a reasonable system you can buy. Now, I'm sure there's many good systems out there for good quality for lower cost, but when we're talking about really extreme high-end stuff, it gets into that kind of pricing pretty quickly, especially when you start talking about some of the speakers that are out there. You know, you can buy some really good ones, but then there's this gap where, like, you know, you get out of the $1,000 pair of speakers and you can easily jump from there to a $5,000 or $10,000 set of speakers. And it's always a debate how much more quality you get for that much money, but you know, I think some of it, if you could listen to it in the right environment and you had the right ears for it, I'm sure it's worth it, or they wouldn't be selling it. People wouldn't be paying that kind of money for it, you know. So anyways, that's that. I had a question on the ICO 950B, the capacitor checker that I did the video on, and they were saying, you know, why does the voltage adjustment potentiometer have to be a wire wound and not a carbon. So let me see if I can dig out the 950B and maybe we'll talk about it a little bit. So here we have the 950B, and if you take a good look at it, hold on a second. Sorry. If you take a good look at it, down here on the left we have this voltage control pot. And if you recall, go back and watch my video on this. This pot was bad. Now, let's talk a little bit about this, because this was a great comment, because it reminded me of some things that I did not mention that I will mention. First of all, how come so many of these that you buy online, the pot is bad? Well, I'll tell you why. When you turn this up, these numbers are real. When it says 500 volts, when you're turning this pot, there's 500 volts going across this pot. Most carbon pots, you know, the carbon track potentiometers, and here is my phone. Okay, I'm back. Duty calls, you know. So anyways, with these pots, these carbon comp pots cannot handle that kind of voltage. So that is why you have to use a wire wound. Okay, now I know why that question was asked, and it's because these wire wound pots, and I forget what the value is. If you go back and look in the video, you'll see they're really, really hard to find. I mean, you pretty much, your best bet is to go do a Google search and sift through page after page after page of, you know, dead ends until you finally hit a place that actually will willingly sell you one online. So and they're going to be new old stock. They're really hard to find, and if you do find a modern replacement for this, expect them to charge you a couple $100, which is not worth it. So your best bet is to find a new old stock somewhere, or find one of these that has a good pot. Now, the reason that these blow, whenever you rotate this pot and you turn this voltage up, it applies that voltage to the capacitor that's on these terminals. And what happens is, as you turn this down, the voltage that's charged up on that capacitor will dissipate back through this wire wound pot. So the idea is, you never want to turn this down. You only turn it up. Once you get your reading that you want, you know, for your leakage, remove the capacitor from the test leads without shocking yourself, or turn this off, okay, you know, onto a different mode or something, you know, back to non-leakage test, you know, like a capacitance test, before, you know, and make sure this is removed before you turn this down. If you turn this back down, it's going to arc and spark in there as it goes down, and it will open up those tiny little, that nichrome wire that's in that pot, you know, that's in the, you know, that the wiper goes across, is like hair. It's super thin, and it doesn't take much for it to burn open. So the other thing would be to modify this, to put a, you know, a switch that you could disconnect, you know, like the Heath kits and some of the other ones out there actually have a charge and discharge switch that'll disconnect that pot from the cap. These do not, so you got to be careful. Hope that answers that question. The next question we have here deals with, I get, and this is for a whole bunch of questions I've had, and I've kind of put them together. Where did you find service manual for X? Okay, how do you find your service manuals? Well, I have a lot of stuff, but for the things I don't have, I'm going to share with you 4 different websites that are kind of my go-to sites. There's lots of others, but these are the go-tos. If you're looking for test equipment service manuals, okay, whenever I do the test equipment repairs, this is probably one of the most comprehensive collections of service manuals for test equipment out there. Okay, they have a lot of different things, but test equipment is mainly what you'll find. It's called the Boat Anchor Manual Archive, BAMA, B-A-M-A. The website, I will show you right there. Okay, BAMA edebris, or edebris.com/manuals. Okay, so that is the Boat Anchor Manual Archive. And if you look through here, for instance, here's ICO. So how about our ICO 950B? Okay, and you can see there's the construction manual and there's the service manual. Now some of them are in the Deja Vu or DJ View format, which you'll need. There's an online reader that you can get for that for free. You can download it, or there's converters that you can convert the DJ View up to a PDF file. But it's all free, which is wonderful, and it's really my go-to site for manuals for test equipment. Okay, the next one excuse me, if we have old radios, you know, we're talking the old tube sets mainly, this is the place to go. It's called Nostalgia Air, and it's nostalgiaair.org, nostalgiaair.org. I'll show you right there. It is nostalgiaair.org. Okay, and I don't use the YouTube editor. You know, I use an editor on my computer, so to put hyperlinks in, I would have to use YouTube editor and things, and I apologize, but I don't have time to do all those things. I know how to do it, and I know I get a lot of requests for things like that, but I just don't have the time. So you'll have to write that down, stop the video, and a little inconvenience, but better than nothing. So Nostalgia Air. This is, again, if I go into resources, and you look, just everything on earth is here, you know, all kinds. So, you know, you want to look at, let's see, Capart Farnsworth radios. Okay, and there's all the models, and if you download there, and then you go to here, it tells you it's out of the Riders Volume 22, and you can view it if you click the eyeball, or you can download it if you click the little disc. Okay, so do a view, and there it is, and there's your service manual. Simple as that. Okay, and it shows you 2 of 2 and 1 of 2. Okay, so that's another site, and you can, some of these have the full-blown manuals with, you know, everything on them. Really nice. Okay, I've found all kinds of oddball radios here that I was able to find, the the Zenith and Philcos and stuff, and you can see it just goes on and on. The Jackson Bell, I was actually able to find some of them on there. We did a video on that. Okay, another site. These next two sites, well, this first one here, Hi-Fi Engine, this has a very organized, of course they have, you know, all kinds of information on this site, and you have to apply for, these next two sites, you have to apply for a membership, and you have to get a membership with them and so forth. It's not hard to do. It takes a little time. But on the Hi-Fi Engine, they have the library, and it's similar to Nostalgia Air, only with audio equipment. You know, old stereos, mostly solid state stuff. They do have some other things, but mostly, this is mostly solid state. So you can go down through here, and, you know, obviously you can see how much stuff there is. Okay, like Conrad Johnston. If we click on Conrad Johnson, it takes a minute. And then here's all, they're all organized, you know, the preamps, integrated amplifiers, preamps, power amplifiers, phono stages, so forth and so on. And you can click on them, you know, Classic 60, and it'll show you a picture of it. It'll give you some information about it, 60 watts per channel. And of course this is a vacuum tube one here, so they do have some vacuum tube gear. And if you scroll down and it gives you the specs of it, it'll give, a lot of times it'll give you the year that it was made. You know, not always, but sometimes, you know, give you a little bit of data, a picture of it. And then you have the, you know, the flyer, sales flyer, service manuals, owner's manuals, all kinds of things. And every device has different amounts of manuals you can download. So that's Hi-Fi Engine. And again, their website address is hifiengine.com. And there it is, okay? Right there. Okay, next one. This is the one for really people that want to learn. I don't belong to this site. I do look into the forums and things. I don't participate. I would like to. I just, again, haven't had the time. Just get so busy. But this is a wealth of knowledge, this Audio Karma. And it's audiokarma.org. And they have forums. And you can jump in them. And just about every piece of gear you can possibly think of, they have a forum on, and there's groups of people like-minded with like interests who discuss and share information on them. And sometimes you can share service documents, they share knowledge that and experience that they have. Really, really good website. Okay, so that's 4 sites that hopefully will get you most of the information you need when you're looking for service documents. Okay. The next question that I have is similar to this last one, and it is, where do I find the large value capacitors brand new? Well, it's kind of a loaded question. It really can be a search to do it sometimes. Obviously, you can find them on eBay, new old stock and new stock. The pricing can be outrageously high, ridiculously low. The quality of the product could be anywhere from it's exactly as described, perfect, to the caps has been sitting on a shelf, it needs formed, it's no good anymore, it's leaking, anything in between. I try to purchase brand new. Now, regular caps, we have all the basic websites for electronic components, but I want to show you that some of these sites do have these capacitors, but finding them is a little bit of a challenge. So I'm going to try to walk you through the process of how I find some of these things. So, for example, I'm going to use DigiKey. All right, DigiKey is an American company that stocks a lot of different parts. A lot of us are familiar with it, have used it. Many of you, probably even foreign, other countries. Possibly, I don't know what the shipping is, but I know you can order overseas sometimes. But how do you find these things? Well, the first thing you do is you go in to the product list, and this will work for, Mouser Electronics, for Newark, MCM, a lot of the companies out there. So we click on capacitors, and we want to find an electrolytic. So the first thing you want to do is we're going to scroll down to here where it says aluminum electrolytic capacitors. Okay, you can see right here, aluminum electrolytics. I hope you can all see. I'm looking through the viewfinder trying to figure out what you're going to see here. It's not always easy. And it comes up with this big long screen. Okay, let me get you all in shot here. It has this great big long screen. And if you look at it, it has all the parameters, the search parameter. Now this is your search parameter screen, okay? So the first thing you want to do is you want to go in and determine what capacitance you need. So let's say we need a 15,000 microfarad capacitor, okay? Well, the first thing I'm going to do is, let's say you need a 12,000 microfarad. The first thing you want to do is don't limit yourself to just one value. Again, if you can get something close to that value, it will work. That's a little bit bigger. Just don't go crazy. So let's say we want to filter from 12,000 clear up to a 15,000. We'll accept any of that. So if you hold the shift key down on your keyboard, and then you go up here while holding the shift, and you click the first one, and then you click this second one, it highlights all of them. Or you can go in here and type in min and max microfarad that you'll accept. You can type it in. Either way will work. Okay, so now you've selected a range of capacitors for the capacitance. Apply filters. Now that zooms you in a little closer to your goal. Now the next thing is what voltage do you need? Okay, now again, we can go here and type in a min. Let's say it's a 35 volt capacitor. So we know we need to have at least a 35 volt, but we'll take anything up to 63 volt. Okay, those are standard voltage values. Okay, that gives us a wide range of voltages. So I'm going to click that. And you can see the results up here. There's still 467 capacitors that match that criteria. Now the next thing I look for is, remember, here's a modern capacitor right here, and it is 6800 at 63 volts. Okay, 6800 microfarad. If you tried to get one of these in the 1970s, the capacitor would be more like this size. It would be very big. Okay, so you want to go something within the dimensions of the cap that you have, and here's where the trick comes in. If you try to use the dimensions of the original capacitor, you're going to find that not very many of them match, because modern capacitors are physically smaller. So when we look at size dimension, okay, this is going to tell you the diameter right here. Okay, and I'm going to zoom you in on this part. See where it says diameter size? Okay, if you look at that, all right, come on camera, do your thing. It kind of drifts here. Okay, it's got a gimbal in it. So anyhow, you see this size dimension. You basically want to choose a diameter that is, let's say the one we have right now is 1 3/4 inches diameter. Okay, I'll click that, and you can see I've already gone down to only one choice. Okay, but if I choose my shift key and I hit all the way down to 1.1 inches, okay, look what happens. I now have 356 capacitors that will match my criteria. All right, so I'm going to apply filters once again. All right, now let's say that we want a high quality, high life expectancy capacitor. So we want an operating temperature of 105 C. All right, so there's two different 105 Cs. You can see one there, and hold the shift, one there. Okay, and 125, so that's even higher end. And that limits us down, as you can see right here, to 154 capacitors. I'm going to hit apply filters. Now then, when we go down to the actual search results, okay, let me move some of this junk out of your way. When we look at the actual search results now, okay, we can sort by the different capacitors. So the first thing I want to do maybe is let's look at the price. Okay, maybe pricing is the most important thing, so I want to sort ascending, right? So if I click this, okay, and it's going to show you the cheapest one we have that matches our criteria is a 12,000 microfarad at 35 volt with snap-in leads, and it's $1.82. That's pretty cheap, isn't it? Okay, $1.82. But look what happens. Quantity available, nothing. So the next thing we want to do is let's sort by quantity available, descending. Alright, oh, sorry. There. Quantity available, descending. Okay. There you go. So, as you can see now, we have a capacitor. And if you float over it, it kind of shows you a blow up of the, what it looks like. It is $5.22, okay? 12,000 at 35, okay? And there's 1,000 of them in stock for immediate shipment, okay? Then you can go through all these other things, and we can now sift through the different prices and the different sizes. And you can see this one is only an inch 1.378 or 35 millimeters in diameter, which is much smaller than our original one that we said was 1 3/4 inches diameter. But you can fit that in most cases. It may not fit in the clamp. You may have to make your own bracket or something when you wire it in, but it will work. And it's actually a superior capacitor to the one that you're taking out, probably, because a lot of those older ones, have a higher ESR. A lot of these newer ones have a lot better ESR characteristics and things. And you can even get into higher voltages, like the next one. It's $10 instead of $5, but it's a 63 volt and it's 15,000 microfarads, and it's very close. It's the same diameter. It's just taller. It's still only 35 millimeters in diameter, but it's taller. That's how I do my search. It's tedious, but you can do it. So there you go. There's your how I find large value capacitors. That's the way to do it. Don't be afraid to deviate from the values a little bit, because if you go a little bit bigger capacitance, it won't hurt. Sometimes the manufacturers back then, capacitors were very expensive when you get to that capacity, and they were physically just too large to fit. So they would use the calculated value that they need. They wouldn't go cheap on it, on the high quality stuff, but it would be just adequate. And quite frankly, if you put a little heavier capacitor for your main filters in an amplifier, it will help the bass response in some instances. So, you can go a little bit, but now don't go crazy, because remember, if you get too large with the capacitors, you can and will damage either your transformer or, at the very least, your diodes, because they can't take that inrush current. The bigger the capacitor, the harder the inrush current's going to be, for a longer period of time, and those things can't take that. And second of all, you're going to blow your fuse, because that inrush current will pop the fuse, because it's just too much. So be within reason. To substitute a 12,000 microfarad and go up to a 15,000, that would work. That wouldn't be a problem. Would I go to 100,000 microfarads? Absolutely not. Okay. Voltage is no problem at all. If if it's a 35 volt and you can only find a 50 or a 63 volt, no problem. If anything, it'll make the capacitor last a bit longer, as long as you don't get ridiculously too high voltage and then the cap can't properly form itself when it powers up. So that, just remember. The next thing is the physical size. If it's a little bit smaller, if you go back to my SX7500 video, I believe I used a little piece of circuit board, and I just made a homemade little board with 2 terminals, and I made a little mounting board out of it, soldered the capacitor to it, and attached it on there, and it actually covered over the space where the larger diameter capacitor used to be. So think outside the box. That's what you got to do. The next thing I've had a lot of comments on is these mica pads, the insulating pads. And I've had some pretty good comments from some of the things that I've said during the videos. And for instance, I commented on the Macintosh amplifier that I did for the Verdun bell tower that I didn't see any mica pads. Well, I found out that The reason, there was one pad on one transistor, and that's the only one that needed to be isolated. The whole heatsink was floating on like a plastic isolator from chassis, and the two elements of the two transistors were electrically connected anyways on the collectors, so it didn't matter if they were shorting through the heatsink. And the only one that needed to be isolated was the one transistor, which did have an isolator pad on it. Now, it is true, some of the older ones, they would use a real thick anodized finish on the aluminum as the isolator. I don't like that, and I don't trust that. So I will always put an insulator on those. On some of the really old Pioneers, they used to use this clear, oily substance for a thermal compound, and it kind of dries like crystally, almost like super glue after a while. And it fuses the mica pad to the aluminum, and it fuses the mica pad to the transistor. And when you go to take it apart, it splits the mica in half. Okay, and when we talk about mica pads, what I'm talking about is these little things here. You can kind of see in here, it's made out of mica, which is almost like glass, and it can crack very easily. And when you take it apart, it just shatters. Those are a pain to clean off. It's just a lot of work. So there's several different ways to thermally couple a transistor to a heatsink. Okay, the direct way would be to just put some grease. Okay, so I have all kinds of different thermal compounds. Here's a common one. This is just inexpensive, good quality silicone heatsink compound. It works great for amplifiers and things. Not good for microprocessors and CPUs, those kind of, for computers. They produce way too much heat for their size. You need, a higher quality thermal compound. Something like this HY700. It has, I believe it has silver, either silver or something like that. It's not the zinc, but there's all kind of things on the websites out there about the different types of heatsink compounds. I don't want to get into that right now. The other thing you can use is these little silicone pads. They do not require any grease. They're direct contact. These ones are okay for low power, but if you tighten the screws too tight on these TO3 ones, they will tear and they could short. But they're good for little power supplies and things. They work. These ones, silicone, you could buy 1,000 of them for $5 if you buy them like this. Catch them on sale. These work really well on the TO220s. You just put them on, no grease, no nothing, and they seem to hold up forever, and they work really well. They do very good thermal transfer, not bad. And then the very highest end, well, there's the beryllium ones. We're not going to talk about those. Nobody uses them because they're $1 zillion. But you can also get these little ceramic ones. And the ceramic is really good in RF applications. If you have a radio and you're setting up a final stage or something, this ceramic is kind of thick. You can kind of see these are a bit thicker than a regular silicon or mica insulator. And that little bit of distance that it puts to the heatsink does a little bit of capacitive decoupling. In other words, it doesn't allow as much capacitance to take place between the transistor and the chassis, which is quite often what the heatsink's attached to. So you kind of need those for those. If you replace one of those ceramic ones with the mica or the silicon, you may end up finding that the finals in the amp are either going to oscillate or it could cause you some really weird problems. And you'll have a hard time troubleshooting it because you won't realize that's what the problem is. It's just a little tech tip there. Okay, so that answers that. The next comment that I got deals with the video I just did on the SA9100 integrated amplifier. When we were looking, if you remember, I was checking for that bad transistor, and we found a bad transistor on the protect circuit that was leaky, and it was causing excessive ripple, like causing the voltage to move around. you know, on the power supply rails. Now, you need to kind of understand why I was doing what I was doing. Hold on. So let me speak to what I was doing and why. Because I think by some of the comments that I had, you guys weren't all kind of following what I was doing. First of all, if you want to measure a capacitor for leakage, you can check the AC ripple on it as part of it, but you can only do it when the capacitor is under load. In other words, you know, this capacitor here, let's see, it's rated at 63 volts, and let's say the DC we're applying to it, you know, through the bridge rectifier, the unfiltered, unregulated, that you're putting on this is, let's say, 45 volts, okay? So theoretically, this will charge up to 45 volts, okay? And I'm not going to get into the RMS and the peak and how you calculate the, you know, 0.707, 1.414. Let's just say, for simplicity purpose, that with all that aside, there will be 45 volts DC on here in a perfect, when the power supply is working, okay? If I put my probes on here and on here, like this, plus and minus, and I set my meter to DC voltage, I should read 45 volts DC on there, okay? And I might read 45 volts DC on there for the most part. But if I go down to millivolts or go to AC volts, I should not see anything because it should be DC. So the AC voltage should be nothing. Now, a bad capacitor can still read good when there's no current being drawn on the circuit, because the capacitor really isn't filling in the gaps of those pulses coming off of your rectifiers. Okay, that's what the one person in the comments was saying, is that this is a bad test if I just hook this up to an an unregulated DC source, you know, like a rectifier, and then don't put any load across it, because the cap doesn't really have to ever discharge, so you don't see the actual capacitance going on in this thing. Okay, so if you put it in the circuit and you apply it to the circuit and the circuit is drawing current, if this capacitor is bad, you'll see AC ripple because this capacitor is not able to charge up as fast as it's discharging. It's not doing its job. It's leaking. Okay? So that's a quick and dirty test. But when you do that test, when you check a capacitor for AC ripple under load, it has to be under load. There has to be current drawn on this cap for that test to mean anything. All right? I hope you all understand that, and I hope I cleared that up. Now, what I was looking for was not necessarily not 100% a capacitor, but possibly a bad capacitor. But those transistors, it ended up being a bad transistor. When a transistor leaks, they kind of short in and out, okay? And as they short in and out, when they short, they drag down the power supply rail. That voltage jumps all over the place. If you're on DC, sometimes you can see it move, but the problem is these meters have a reaction time, you know. So I'm set on ohms. I just touched those leads and I didn't get much of a reading. See how I actually have to hold it. Look how long that took. Voltage does the same thing on these. Now you can set the range to a single range and it'll react faster, but it's still, there's a delay. All right. However, if I put my leads across that DC with that leaky transistor shorting in and out, and I go down here on AC, I can actually see, even though the frequency is not 60 hertz, I can actually see that varying voltage as a kind of an AC ripple. Okay, then I can move to DC and sometimes see it move around a little bit. So that's kind of what I was doing there. All right, by doing so, it was giving me an idea of what the problem was. I was able to probe around. Again, I was kind of doing that to show you that you don't need a bunch of expensive test equipment to troubleshoot some of these even more difficult problems. I could have easily put a scope on there, looked at the waveform, and it would have been a piece of cake. But what if you don't have $300, $400, $500 for a scope, or you just don't have a scope? Well, this is an alternative you can use. I do it all the time out in the field, and it works very well. I mean, I've repaired, $250,000 X-ray equipment with that method, and very quickly found the problem. So that's kind of what I was doing. But I just wanted to give you those little updates on, that capacitor being under load if you're checking a cap for ripple. Okay. All right. Okay, the next question or comment that we had was, I mentioned about the rectilinear 3 speakers would sound good with that amp. And I just thought I'd throw that out there to hear what kind of other responses I'd get. And one of the ones that came up was the JBL speakers of that era. And boy, those are awesome speakers. Far superior to the rectilinears, probably. But I really like hearing everybody's opinions because, there's so many options. As far as the rectilinear 3s, like I said, my cousin had a set of those many, many years ago. And it just impressed me how they sounded. I mean, they're really big cabinets for just having a 12-inch driver in them. And then there's a whole bunch of little tweeters scattered around all over the front baffle, which don't seem to make a whole lot of sense how they're laid out in there. And it does, as the one viewer commented, it does affect stereo imaging. They're not the most directional speakers on earth, but they just had like an old sound to them. I mean, they had instead of a foam surround or a soft surround woofer, they had more like an accordion style cloth, laminated. So they had kind of a stiff compliance speaker, and they had a large volume cabinet. So they had that deep old tube amplifier kind of sound to them, from the older days. And I kind of like that sound. I mean, it's certainly not a very accurate sound, but it just has something that reminds me of classic times, older times. So I just kind of think they're neat speakers for what they are. Another person mentioned the Advents, and of course those were spectacular. Advent, the original large and small Advents, and then the later on ones, great speakers. Had mention of some of the, what else? Quite a few different ones, but great comments, so thank you. The next question was it was off of the SA7500 restore video, and it said, can we hear more of the demos? And certainly I would like to do that, and I do have some plans for doing that. But what I want to do is make it easier for me to quickly connect these up to my big speakers to my system. So I'm building a new component rack down in the wood shop. I have some other projects that I'm working on currently. We're building a new little maker's bench and computer desk for my son. And when that's all done, I'm probably going to go ahead and build another component rack that I can put test components on with switching and so forth to easily connect the speakers and switch over. And I'm going to start to do a little bit more of that. And I know the recording and the compression that YouTube uses and everything, it's nowhere near what it sounds like live. But I know I've got so many people who like to hear that, that for their sake, I don't mind doing that. So, not a problem. Just so you know, you get whatever all the software and the compression and the YouTube algorithms and everything, that's what you're going to hear. You're not going to hear what I hear. And even if you stood here next to me, you wouldn't hear what I hear because my ears are different than yours, most likely. But it's really cool to see, and it kind of puts a finishing touch to the video. I agree, and I don't mind it. So whenever I have the time and I can do something like that, I will. I won't do it on every single one because it just would take too much time that I don't have. So thank you for that comment. The next one was from the Adcom preamp that we did, the GTP 500, I think it was, or 450, I forget. How I went through the process of cleaning the slide switch. Now remember, those knobs are rotational, but they're actually, all it is turning a little cam that's activating a a slide switch, that you normally see in the Pioneer and Marantz and Sansui, so many things of that era. So I'm going to kind of just show you how I do it. And before you service engineers, you people that work on these totally gasp and have a heart attack, I'll just tell you that it is kind of a touchy way that I do it. Not recommended for people who aren't comfortable with touchy work. But I've kind of done this for a long time, and I've never had any problems with it. So, and I'll kind of explain myself as I'm going along. So let's get some things out and I'll show you. Okay, for some reason, before I go any further, probably a year or two ago, I did a video on just a basic of how a CAT scanner works. And for some reason, that thing gets so many hits, people watching it and so forth. It's just unbelievable how many people watch that video. And unfortunately, the video format that I recorded it in, it was kind of on location. I was in the middle of a service call, so I didn't have a lot of time to do very good recording. And I kind of just threw it up there as just a fun thing. And when it went through, it's perfect video on this end, but twice I tried uploading it to the YouTube channel, and when the YouTube encoded it, it made the image very choppy. But I get so many comments on that video, and people seem to be interested in things like that. I'd like to do some more of that. If you guys are interested in that, I do a lot of CT work. If, maybe I'll do a better video if there's that kind of interest in it. I don't know. Like I said, this channel, I kind of not just audio only, although audio is a big hobby of mine. I put other electronic things on there, as you can see from time to time, with some test equipment and different things like that. So, just wanted to let you guys know on that and kind of hear your comments, what you think about it. If you think you would like to see a little better video on how CAT scanners work, maybe we'll do that. And maybe we'll get into some of the fancier multi-slice scanners that are a little more modern. I don't know. We'll see. Let me know. The next thing in line is, if you recall, this is the quasi-complementary stereo amplifier kit that I got from China that was very cheap. It was like $7 or $8, including all this semiconductors and everything. And I put this thing together, and as you could see, I was able to get it to work, halfway. And it is plagued with design flaws. Okay, we all know that. It's actually didn't sound bad, and it actually, it wasn't super high power, but it worked. But would it be something I would use as a daily driver? No. Maybe it's something I'd just stick this board to something and hook up a cheap power supply and a little transformer to it, and maybe to be able to listen to the radio out in the garage if I'm working on my car. But other than that, no. Many flaws. Number one, these are 1N4007s, which anybody knows is your ubiquitous 1,000 volt 1 amp diodes. Very cheap. You can get them for just a penny a piece sometimes, or less, in big quantities. But a 1 amp diode is nowhere near the current capacity you would need for an audio amplifier, especially a stereo audio amplifier where you're driving two separate channels. Secondly, so that's would have to be changed. You'd have to put bigger diodes in there. These transistors are good transistors, but they're undersized for the job that they're supposed to do. Now, if everything's biased properly, you certainly can get them to work, and you know, they're adequate. But there's no room for error with these. There's no current protection, no current limiting resistors, nothing. So if something goes wrong, these are direct coupled amplifiers. These will burn up almost instantaneously. You can't pull the plug out or disconnect the power as quickly as these will go bad. So that's another bad problem with them. Another issue is no current limiting on the outputs, no Zobel network on the outputs, and no snubber inductor on the outputs, and no speaker protection on the outputs. All very, very bad things for the transistors and very, very bad things for your speakers. So if you don't use very cheap speakers that you don't care about, you probably want to reconsider your your choice. Now, that being said, they did come out with a different version of this for the same price. They added a Zobel network. They added a bridge rectifier and did a couple things like that to try to make it a little better. And I actually was fully intent on trying to make and modify one of these to make something decent. Now, let me show you something. Alright, as you can see, I made up, you know, a little box, and here, let me show you real quick. Just made up a little box. And as you can see in here, I basically built one of the new style, which, you know, has, if you notice, it has a position for a bridge rectifier that came with it as the kit. It puts the power supply in the center instead of off to the side. It does have a little Zobel network. You can see that's what that is right there, those two components. So they made a few differences. The bias obviously was a problem, because now where there was only one voltage elevating diode for the bias, they now have two. So it increases your bias a little bit to kind of get you better centered, like what the mods that we had to do on that original one. But here's the bad thing. I took these off here, put them on a regular heat sink, you know, put the transistors there, built a little you know, kit from a kit, a little speaker protect board, which is not hooked up right now. Took the power supply and kind of took it off the board and put a proper bridge rectifier and a couple of nice beefy capacitors to go in combination with these. I put this whole mess together, and I was going to do a video on it, and lo and behold, it just stinks. It's terrible, guys. I cannot recommend buying these kits. I know I said that it wasn't too bad on that first video, but really, after spending time with it, it's horrible. Don't do it. First of all, you can't adjust the bias. So if you're, and for some reason, even building one of these, I built another one of these boards bone stock with everything the way that it's supposed to be, and the bias was still a turd, just like the first one. And being unadjustable, if it's too far out, one of these transistors will fry immediately, which is a big pain. I've tried some different things, and the bottom line is, without major changes, it's just not worth the hassle. Don't waste your money on these. You're not going to see a video on this because I've pretty much abandoned the project, and I just don't think this is a viable option for somebody who wants to build their own amp from a little kit very, very, very inexpensively. Since then, I have found another kit that looks promising, that looked interesting enough for me to take a chance and buy it. It was a little more money. I think it was like $15 or $18 with free shipping. But it was based on a Sanyo STK style output power module. Now, any of you who are not familiar with what I'm talking about, Sanyo, back in the 1980s, came out with a complete line of basically amplifier modules. They're a little square module about that big with pins coming out of the bottom, and they directly flat mount onto a heatsink. Very easy to heat sink them. And inside them, it's not really an integrated circuit like you would think of a normal IC, you know, like a 74LS series or something. It's more of just a bunch of components all mounted onto one substrate. So you have your driver transistors, your phase inverter, your pre-driver, your outputs. Everything is on one block and then sealed inside the module. Okay? And the nice thing about that is that everything will track at a uniform temperature, so that keeps them all thermally stable. It keeps the components are direct connected internally, so you don't pick up noise, so they're very, very quiet. Sorry, a call came in. Anyways, those STK modules, everything's all in one package, and you know, the noise level is low on them, so much so that companies like Fisher, Pioneer, you know, like on the SX780 and those ones, they went to those modules and they had surprising performance because of the way they were designed. A lot of people mistake that for a cheap integrated circuit, but those are actually the same transistors, the same semiconductors that were in the discrete packages like these TO3s, but instead of being in this metal case, the two were put in one case together next to one another and pre-wired internally. So with a minimal of components, external components, you have a really high quality amplifier. And I found a company that's making a kit out of these that's only, like I said, it's like $15 or $18, and it's a 50 watt per channel, true 50 watt per channel amplifier. So I'm going to get that and try it out and see, and we'll look at the results. So anyhow, that is the update for the quasi-complementary power amplifier project. It is officially dead right now, and I'm telling you. All right, let's go to the next question. The next question deals with the bass amplifier, okay, that we just did the video series on. And the question was that when it came to building the cabinet, did I calculate the box volume, the resonance points, and the frequency for the ports that I put in? And long story short, no, I did not. For a multitude of reasons. Number one, I really didn't want the cabinet to resonate at any frequency that a bass plays, because then that makes the bass have hot spots and cold spots. I did want the thing to sound kind of open, so I did not put any kind of stuffing in the cabinet. I used pine, which is kind of, you know, it can resonate a little bit, but not at a, you know, it sounded pretty good, but I wanted to open it up a little more, and I had those two ports already in stock, so I placed them in there. They're not a big, large diameter port, so they're not it's not tuned to a real low frequency. But you know, basses really aren't the same as a kick drum. You know, they're not. They go way down there, but not as low as like subsonics or anything like that. So I just experimented, and it sounded good. I'm happy with the way it is. The other question was dealing with when I was talking about the amp has too much gain and also has some hum that I'm going to deal with. And I had a lot of great recommendations. One was to substitute the 12A-X7 at the front end with a 12A-Y7, which is a similar tube with, you know, lower gain. The other was to bypass the first tube altogether and use the second tube. Just in other words, eliminate one stage from the preamp. And certainly we can do that because of the way the feedback and everything works in this particular design. I am going to try some of those things just for the heck of it to see how they work, and that will be in the follow-up video when I get around to it. So great suggestions and comments on that. Thank you. The next one was on the SX750 video. I get a lot of recurring questions about those two transistors. If you remember, I had a dual transistor pack, and let me see if I can find it. So here you go. This is what it was, and basically this is a 2SA798, tiny little thing, and it's basically, if you notice, it's only 5 pins, even though a transistor has 3 pins on it. Instead of 6 pins, there's 2 transistors in this one package. But one of the terminals is internally connected of the two, elements. So there's only 5 wires. And because of that, this transistor goes bad in Pioneer gear a lot. And they're getting very hard to find. There are places that sell them on eBay and so forth. They're not reliable places. Sometimes you can get them, sometimes you can't. I found this one. They were brand new, and they're supposed to be original 2SA798s. You can actually see the numbers on it when it came in. The unfortunate thing is these internally are wired differently than the originals used in the Pioneer. Even though they're the same exact part number, they are not compatible because the internal elements that are wired together, I think for instance, instead of the emitters being wired together, the collectors were wired together or something like that. I forget. But the bottom line is that did not work. So what I did was I replaced it with 2 discrete transistors, if you recall. And they had metal cans on them. They were metal cased transistors. And if you recall, the circuit board on the SX750 was designed such that you could use one of those dual package modules like that, or you could put 2 discrete transistors. The holes were drilled, the silk screening was on the board, everything was there. Go back and watch the video, you'll see what I'm saying. So I went and put the 2 discrete transistors, and I got a lot of questions and comments, and I'm still getting them today. Can you do this? Will they go too far out of balance that it'll affect the distortion values and things? And long story short is, yeah, you have to use matched transistors, very closely matched. So if you have a curve tracer or some method of measuring the gains and matching the transistors, I highly recommend it. Number 2, temperature doesn't seem to be a big deal. As a matter of fact, I use that receiver a lot, and I've never had a problem with distortion or with anything like that. It was just, I never had a problem. They work fine. I had a lot of suggestions. Can you encase them in epoxy? Can you, tie some kind of a heat sink between the two to share the... You probably could. And if that were necessary, you could probably use a thing called potting epoxy or something like that, or use thermal epoxy. That's this stuff. I get it. It's basically it's heat sink compound that is kind of impregnated into glue, so it hardens like glue. It sticks like glue, and you could probably use something like that to make up your own modules. I just don't think I need it. It works fine. I haven't had a problem with it. I put the 2 transistors in and forgot about it and never had a problem. So if I see a problem moving forward with that, I may experiment with something like that, but as for right now, you're just fine putting in 2 discrete transistors as long as they're properly matched. Okay, last but not least, and I'm sure this has been an epic length video, but it really takes a lot of time to get through all these, and I'm sure there's a lot that I missed. I apologize for that. I'll try to catch it on the next one around. Like I said, just to give you guys an idea, in the length of time that it's taken me to make this follow-up video, which is about 2 days that I've been taping this on and off as I had time, I got probably another dozen comments. It just happens that fast, so it's hard to keep up. I'm not going to claim that I can or will keep up, but I'll do my best to try to combine questions and address them as I can. If I have time to type you a quick response on a comment, I will. If not, my apologies in advance. Last but not least, I had a couple comments on my video disclaimer at the front that it's kind of shocking. Death can occur. I mean what I say in that disclaimer. Read it. It's on all my videos. This is not a hobby that is entirely safe. You have to use common sense. You have to understand what electricity can do, what its potential is. You have to understand that you can get hurt. You can even be killed by electricity. Electrocutions are no joke. They really happen. And the last thing I would ever want to see is any of you to ever receive any kind of injury by trying to imitate something that I'm doing, and not having a full understanding of what you're doing and then getting hurt. I know I get a lot of comments about the ring and the watch. The watch I probably should take off. Sometimes I do, sometimes I don't. And it depends what part of the circuit I'm working on and how I'm doing it. The ring's been on my hand since I got married. It doesn't really come off. But yes, I could wear a glove or I could put some tape around it. And, I do sometimes. But, it's 41 years now I've been doing electronics. And 30 years in the X-ray business. And I've never had a problem, thank God. I appreciate, I'm thankful. But, you kind of learn how to do things. You don't want to ever let your guard down. But you just have to make practices that work for you, that ensure that you're going to do the same thing the same way every time in a repetitive manner so you don't hurt yourself. And you always have to be aware of where your hands are and where the unsafe things are in what you're servicing. So, yeah, I kind of wanted that to be a little bit of a shocking statement at the beginning, because a healthy fear of it is good. An unhealthy fear, of course, is not good, but a healthy fear of electricity and what it can do, and a respect for it, healthy respect, is very important. Before you decide to ever work on any of these things, know how this stuff works, Lots of people on their videos will tell you about using an isolation transformer on hot chassis radios and how to do things. Unplug things. Make sure use the Stinger cable. Make one of these up with the resistor to discharge unsafe capacitors. Understand how your circuit works inside out and backwards before you put your fingers in there, before you work on it. Make sure first of all you protect you. You can get another radio, you can't get another you, okay? Well, that kind of wraps up this video, and like I said, I don't even know how long it is until I get it up there. I will tell you up front, I am not going to do a lot of editing or commenting on this video because I don't have the time right now. I've got a lot of projects to do, so I'm just going to probably stitch all these clips together and process them and get them uploaded and posted. The main purpose of this video really was to answer your questions and try to kind of make your voice heard a little bit. Each time I do this, I want to try to get a little better at it, and I want to try to do one a month if I can, and maybe get you all to participate in it a little more if it's something you like. I don't know. So, and then the other thing I wanted to ask all of you, and this is a question for all of you that I have, because I don't know about this stuff. I'm not a big video, kind of person. This is something I just started doing off the cuff. But I notice a lot of people using Patreon as a kind of as a means to subsidize the expense of doing their videos and things. And I don't know a whole lot about it, and I don't even know if it's something that would be appropriate for what I'm doing, but I'm kind of looking for ways. Of course, when I do a work for a customer, I charge, not a lot, but I at least get money for the components and stuff that I do, and a little bit of money for the work that I do. But just looking for some options to be able to kind of offset some of the expenses of doing some of these videos, because I'd like to do a little more complicated videos now, since I'm learning more about these sorts of things. Just wondered what you guys would think of if I got into something like that would be worth my while. And the other thing is, I'm going to probably sell off some of my gear, because I really got to thin the herd. I don't have the storage for a lot of this stuff now. It's collecting up, and I do like my marriage to be happy. I'll keep it that way. So when I post some of that stuff up there, I'll let you all know. And that would be another thing. And then for those little radios, maybe what I'll do when I do those little time waster sets, I'll probably give them away to some viewers. I think that might be a good thing to do. Maybe just if you guys can pay the shipping, or the couple dollars worth of components, I'll be happy to give them out and kind of pass them forward for other people to enjoy. I don't know what you all think about that, if that would be something interesting. I don't know. So let me know. For now, we're going to call this a wrap. And again, I wish you all well. I wish you all the best of health and joy in your lives. And as always, don't keep the faith, share it with others. See you for now.